Okay, so having looked at multiplication of fractions, let's take a very quick look at multiplying decimals. With decimals, we have a standard algorithm that says line them up, multiply the fractions, and then count the number of place values you've got, right? And add the total number of place values, and that's what the final answer is going to have. So this is a bit problematic because we know that if the final answer has a trailing zero, then some students will lose that trailing zero. So it becomes problematic, and it also is very procedural, right? So counting decimal places is procedural and does not make much connection. Okay. However, let's at least make sense of it, and then I will show you a different way to understand multiplying fractions. So let's at least make sense of it. So let's say we have 1.36 times 2.7. Now, working with decimals is almost as much fun as working with fractions. So if you're multiplying out these two numbers, I would much rather have multiply out just the digits, right? So without the place value. And we know that the digits in that final answer are going to be the same as the digits in the original problem. But for example, if you multiply 1.2 times 3, right, you would get 3.6. The digits without the decimals are the same as if you were multiply 12 by 3 to get 36. And in fact, 0.12 times 3 would also give you the same digits. It's just the place value of each of the digits changes. That we talked about that happening when we were multiplying by 10 or dividing by 10. It's the place value where those digits exist that changes. So if we can get the digits, then we can compensate for this place value later on. So for example, when we're actually looking at changing from 1.36 to 136, what we're really doing is we're multiplying by 10 twice. So multiplying by 10 once will get us 13.6, and multiplying by 10 again will get us 136. And 2.7, to get to 27, we need to multiply by 10 as well. Now we're in the clear, we have no decimals at all. And let's multiply that out, and let's say we go through this whole process and we get 3,672. But when we had 3,672, we got there because we had multiplied by 10 3 times to drop off the decimal. So if we want to go back, wouldn't we need to divide by 10 3 times, right? To get back to the original value that we had. So instead of 3,672, we would divide by 10 and we would place our decimal after the 3. Okay. So this is kind of editing the value of the number, the place value of the number, temporarily to make it easier to calculate, and then compensating for it at the end. Now, so, however, there is an even better way, I think, a more conceptual way to be multiplying decimals. So let's say that we are able to say 1.36 times 2.7. And we know that from just a straight calculation that the digits are going to be 3,672. Now, we have some options of where to put our decimal place. So what if it's over there? Now, is it possible, let's look at the values of these, that we multiplied something that is about 1 by something that is about 3, and we get 367, right? It cannot be 367 anything. So it's impossible that the decimal would go here. How about here? If we multiply about 1 times about 3, is it possible for us to get 36? It is not. Is it possible for us to get 3.6 something? That it is. Is it possible for us to get 0.3 something when we multiply something around 1 by something around 3? It is not. So this is not possible. So the only place where the decimal could really go is after the 3. Right? So you can use estimation to be able to figure out where the decimal should be going, right? By making sense of those numbers. You know that by removing the decimal, you can get the digits. But by using using number sense of what those numbers are, what the value of those numbers are, you should be able to then identify where that decimal point will go, and what place values are represented by those digits. Okay. And then using that, you can make sense of why we're using why the decimal place rule works for multiplying decimals.